Okay, so in this lesson we're going to talk about composition of functions, and let's kind of review something from the previous lesson. And the previous lesson was where we were talking about combining functions. So remember, in the previous lesson we took two functions and we added them together and we got a new function. We took two functions and we subtracted them from each other and we got a new function. We took two functions and we multiplied them together and we got a new function, and then we took two functions, we divided them, and we got a new function. All right, but notice the notation. The notation is important. So when you see f plus g at x, remember that's how you read this, f plus g at x, then that's the same thing as saying f of x plus g of x. F minus g at x is the same thing as saying f of x minus g of x. F times g at x is the same thing as saying f of x times g of x, and then f divided by g at x is f of x divided by g of x. Okay, now let's kind of review something first. So remember, and you've had this in previous semesters and also this semester, but so if f of x is this function here, so this is your function value. Remember, a function just takes one set of numbers and maps it to another set of numbers, hence the domain range idea. So you have a set of numbers in your domain, and it's mapped, remember domain, and it's mapped to a set of numbers in your range. So that's a function. That's domain. So that's the idea of a function. So what I want to do here is I want to take the input 3. Remember this, the domain can also be considered the input, and this would be the output. So I have this input, this number 3, and that's going to be my input. So wherever I see the variable x, I'm going to replace it or input the number 3. So I'm going to go to my function f. So this is my input. I'm looking for this output. So I'm going to go to my function f, and wherever I see the variable x, I'm going to substitute 3. Okay, so basically you're taking the number 3 and you're going to input it into the function f, and you're going to get an output called f of 3. That's what you're finding. Okay? And so when I go and I do this evaluation here, f of 3, I'm going to get 3 times 3 squared minus 7 times 3. And so 3 squared is 9. 9 times 3 is 27. Minus, and then 7 times 3 is 21, and so I get 6. So that means that f of 3 here is equal to 6. That's what I just found. All right? Now, so that was a review. Now, what if I had this? Okay, suppose I have, let's call this number 1. Number 1. Suppose that f of x is 2x minus 1, and g of x is 3x plus 2. All right, so f of x is this function, and g of x is this function. Okay, now let's suppose I want to find this. So let's call this this a. Suppose I want to find, let's say, g of 6. All right, so remember what that means. That means for the input 6, I'm going to go to my function g. I'm going to input 6. So I'm going to go to my function g. So in your mind, you're saying this. So I'm going to put 6 into the function g. I'm going to get some output called g of 6. So remember your y value. So this says what when x is 6, what's the y value? So remember, when x is 6, what's my output? What's my y value? Okay. So g of 6, remember what that means is you go to function g, and where we see the variable x, you're going to substitute 6. So I get 3 times 6 plus 2. So 3 times 6 is 18. 18 plus 2 is 20. What about this? Suppose you had f. I'm going to go ahead and write the notation first. So this notation, then I'll tell you how to read it. So let's say it was this. All right. Okay, so you read this like this now. This is read as f of g of 2. That's how it's read, so it's important you read it correctly. Don't say f times g times 2, because remember, you know how to read this. This is read g of 6. All right, so you know how to read that. So the same thing here. So this is g of 2, so this would be f of g of 2. All right, so don't say anything about multiplication here. So f of g of 2. So the f is listed first, so that's listed first. G is listed second, that's listed second. So f of g of 2. All right, but let's look at this right here, and let's use this diagram for to help us. So this says my input is 2. I'm going to put 2 into my function g, and I'm going to get some output g of 2. That's what that said. Okay, so I'm going to have my input 2. I'm going to put that into my function g, and I'm going to get some output called g of 2. All right, so I got to find what this output is. So when I put 2 into my function g, so when I put 2 into my function g, I'm going to get, so g of 2, I'm going to get 3 times 2 plus 2. So where we see the variable x, you're going to substitute 2. So I get 3 times 2 plus 2. So that's 6 plus 2, which is 8. So this right here is 8. Okay? All right, now what that says here is this now. So remember, that says I take my function, I input the number 2 into my function g, and I'm going to get some output called g of 2. But that output is going to be an input into f. So I'm going to take that output, and I'm going to put that into the function f, and I'm going to get some output now called f of g of 2. That's what that says. So I have some input g, some input 2 rather, I'm going to put into the function g, and that's going to be my output. And that output is now going to be an input into my function f, and I'm going to get an output again. So input, output, input into here, and you get an output. Okay? All right, so basically, remember this is 8, right? So this says I'm going to take 8 and put it in my function f. So now I'm going to go to my function f, and I'm going to find f of 8. So let's find f of 8. So f of 8 then would be 2 times 8 minus 1. So we see again wherever we show the variable x, you plugged in 8. So 2 times 8 minus 1, so that's 16 minus 1, which is 15. So that's what this equals. This equals 15. So that equals 15. So notice what this means right here. What this means. So this means I find g of 2. So g of 2 is 8. So remember how we found this. I go to my function g, where we see the variable, I plug in 2. So when I go to plug in 2, I get 3 times 2 is 6. 6 plus 2 is 8. So that's what this is. So now I'm going to input this into f. So I'm going to take this now, put into f. So basically what's happening is this. Now watch carefully. So I'm going to go ahead and rewrite this over. So what we found was this. So I'm going to put it right on each other to show you. So remember, we found what g of 2 is. What's g of 2? 8. So replace g of 2 with 8. So that becomes f of 8. And then how do you find f of 8? Well, we take 8 and put into f. That's what that means. See this right here? F of 8 means take f, put into the function f. And so when I take 8 and put into the function f right here, I get f of 8 then would be 2 times 8 minus 1. So that's 16 minus 1, which is 15. Okay, so therefore, in the blank, you would put, for f of g of 2, you would put in the blank, you would put 15. That's what you put in the blank. All right, now, let's suppose we had C. So when we do C, I'm going to skip all this diagram right here. I'm going to skip the diagram. I'm going to do it exactly the way most people will do this. So C, you'll say, let's find this. I suppose we had this. Okay, so what you can do first, remember this right here. So this says I look at g of 2 first. So I looked at the function that's on the inside, so the innermost. So the innermost is I got to find g of 2. So to find g of 2, when we go to function g, where we saw the variable x, you plugged in 2. So where we saw the variable x, you plugged in 2. So you said 3 times 2 is 6, plus 2 is 8, and so that's how we got that 8. So right here, I'm going to find f of negative 2 first. So what's going to do? F of negative 2. So remember, that says I go to my function f, and I'm going to input negative 2. So f of x, remember, is 2x minus 1. So now this is going to be, again, where we see the variable x, you plug in negative 2. So this is 2 times negative 2 minus 1. So that's negative 4 minus 1, which is a negative 5. So I found f of negative 2. So f of negative 2 is this. So then I go and I replace f of negative 2 with this. So f of negative 2, what I'm saying now, f of negative 2, see that this was the output. When I input negative 2, I got this output called negative 5. This output negative 5. So now this output negative 5 then becomes an input to my function g. So I'm going to take negative 5 and I'm going to input it into g. So remember g of x, I'm going to go ahead and write that here. G of x, remember, was 3x plus 2. 3x plus 2, that was g of x. So wherever I see the variable x, I'm going to plug in negative 5. So that becomes 3 times negative 5 plus 2. So that becomes negative 15 plus 2, which is negative 13. So your answer for g of f of negative 2 is equal to negative 13. That's the answer. All right. Now notice that in each of these cases here, A, B, and C, I inputted in the original problem, I input a number, a real number, and my answer ended up being a real number. So g of 6 was 20. I input a real number, so I input a number into g, and then this was a real number, so I input that into f, and it ended up with a, let me see if I can find the answer. Where's it? Right here. So the answer was 15. Here, I input a real number into f, and then remember this was a real number, negative 5, so I input that into g, I ended up with a real number, okay, for the answer. All right, now let's look at this. So this would be number 2. Okay, number 2, suppose you had this. Suppose f of x is 2x plus 3, and g of x is 3x minus 5. So 2x plus 3 and 3x minus 5. And let's suppose you want to find let's suppose you want to find f of g of negative 4. So f of g of negative 4. Okay, so again, what you would do is you'd find g of negative 4 first. So let's find that. And so I'm going to input negative 4 into the function g. So there's g right here. So it becomes 3 times negative 4 minus 5. So again, wherever I saw the variable x, I plugged in negative 4. That's what that means. So this takes the place of x right here. And so I get negative 12 minus 5, which is negative 17. So that's g of negative 4. So now I'm going to find, as I'm doing now, so I found this, and I'm going to find f of negative 17. That's what I'm going to find next. So now I'm going to input now negative 17 into f. So I'm going to get 2 times negative 17 plus 3. So that's negative 34 plus 3, which is a negative 31. So f of g of negative 4 equals a negative 31. Okay? All right, now before we go on, let's talk about this. Okay, so what we should notice is this. In part B, I took whatever g of 2 was, and I put it into f. Okay? I took whatever f of negative 2 was, and I put it into g. I put whatever g of negative 4 was, and I put it into f. Okay? So let's look at this, B part. Let's suppose you want to find this, f of g of x. Okay, f of g of x. Now, I'm going to do it just like I did this one here. So watch the steps. So when we go back and did this, remember I found this first. I found g of negative 4. So I went out and I figured out what g of negative 4 is. So g of negative 4 says I go to my function g, and where we see the variable x, I substitute negative 4. So I get 3 times x, which becomes negative 4 minus 5. Negative 12 minus 5, which is negative 17. Then I took that and I put it back into whatever g of negative 4 was equal to. So g of negative 4 is equal to negative 17. So then I'm going to take negative 17 and put into the function f, And so I get 2 times negative 17 plus 3, which is what this is, and I ended up with negative 31. So this whole expression here, f of g of negative 4 is equal to negative 31. Now, again, whenever I substituted real numbers into these, I ended up with real numbers. Here, though, that's not the case. I'm substituting g of x. So let's go off to the side, just like I did this, where I went and found out what g of negative 4 was. Let's go off to the side and ask ourselves, well, what is g of x? Do I know g of x? Yes, you do. G of x is this. So g of x is 3x minus 5. You're going to take that right here, this expression, and you're going to replace g of x with that. So that becomes f of 3x minus 5. That's what that becomes. So I want you to notice something. Just like this. Remember, we found g of negative 4. So I replaced g of negative 4 with a number, with a real number. Whatever g of negative 4 was equal to. Just g of negative 4, when we did all this work, we got negative 17. And then I'm going to take this and put it into the function f. So just like this, g of x, replace g of x. Replace it. What do I replace it with? Well, replace it with whatever g of x is equal to. Replace it with 3x minus 5. And so that's what you get here. Now I'm going to take this right here. I'm going to go ahead and rewrite f of x. So f of x is 2x plus 3. Now listen carefully. So remember, this says where we see the variable x, you're replacing it with 3x minus 5. That's what that says. You're replacing the variable x with 3x minus 5. So right here, you're going to replace this x with 3x minus 5. So f of 3x minus 5 then becomes 2 times 3x minus 5. Notice the parentheses, because all of this expression, whatever you're replacing x with, 3x minus 5, has to be multiplied by 2. So hence the parentheses, and you can now distribute this. And then don't forget that's going to be plus 3. So 2x, I'm replacing x with 3x minus 5, and plus 3. Now distributing, I get 6x minus 10 plus 3, so that's 6x minus 7. So that is f of g of x. So f of g of x is 6x minus 7. Okay? All right, so notice I tried to make whatever we did here look very similar to this. Except here, when I substitute numbers, when I substitute a real number, I end up with a real number. Here I'm substituting a variable expression, so I end up with a variable expression. I don't end up with a real number. What I want you to notice now at this point is this. All this discussion leads us to this fact. Composition of two functions. Composition of two functions. And so notice I took this function here and I put it inside of another function. So I took g of x, which is this, and I placed it inside of f of x. Where was it? Right here. So I placed it inside of f of x. That is composition. So I'm taking one function. When you take one function, put it inside of another, that's a composition. So composition of two functions is where you take one function and place it inside of another. Okay, so you take one function and place it inside of another function. That's composition. So that's a composition. So whenever you see f of g of negative 4, remember that phrase, f of g of, that's a composition. So f of g of x, remember you read this as we read this here. I'm going to read this as f of g of x. That's how I read this. That's a composition. Composition. All right. Now here's the notation. This is notation. So notation will be important. Okay. So listen carefully to the next statement. Okay. So we call f of g of x. Remember how we read this. We call f of g of x the composition of the function f with g. So remember, that's called the composite functions. Okay, so f composed with g of x. So that's called composition of functions. Composition of two functions. So f of g of x is where we're composing. It's a composition of the function f with g. Now the notation is going to be important. So here's a notation. So here's a notation. So I'm going to rewrite this over. This is how it looks. The notation for this, for the idea of composition, is this. See how f is listed first? So there's a difference between something that looks like this and something that looks like this. Okay? They're still composition. These are still, both of those, you're composing two functions. But here you're taking g of x and put it inside of f. Here you're taking f of x and putting it inside of g. Those two functions, these two compositions, are not always going to be the same thing. So this is not necessarily the same thing as this. Okay? Sometimes it can be, and sometimes it won't be, will not be. But in any case, the notation I'm about to write is going to look a little different. So, remember see how f is listed first here and g is listed first here? So this is how it's going to look. You're going to put f first, you're going to put g first. Okay? And then you're going to say, in parentheses, you're going to put this in parentheses, you're going to say f, now open circle. So it's kind of like a smaller letter O. So f, open circle, g, add x. So f, open circle, g, add x. It looks like the word fog. So f, open circle, g, add x. So that means composition. Whenever you see the open circle right here means composition. Okay, composition. That's an open circle. So here you would say parentheses g, open circle, f, add x. All right, so f, open circle, g at x means this. G, open circle, f at x means this. Okay, but notice that this means composition. So f composed, so you're going to read this as f composed with g at x. So f composed with g at x. So remember when we did this, if I can find it, what did we write? It's all right here. So we call this right here the composition of f with x. So f is listed first. You say f with g. So f with g. So this is going to be read as f composed with g. F composed with g at x. This you're going to read as g composed, open circle composed, with f at x. So g composed with f at x. F composed with g at x. Okay? All right. Now, let's look at this example. Let's call this number 3. Suppose f of x is 2 minus 5x and g of x is 3x minus 6. All right. So f of x is 2 minus 5x and g of x is 3x minus 6. All right, A part. Let's find, now this is how it's going to look. Let's find this. Okay? All right, now you got to know your definition though. So what does that mean? So when you read it, you read it as f composed with g at x. That's how you read this. So you read it as f composed with g at x. But by definition, and here's your definition right here, so f composed with g at x is this. By definition, this is equal to f of g of x. That's what you want to rewrite this as. So the first thing I do is rewrite whenever it's in this form right here, whenever it's in that open circle, you're gonna rewrite it as f of g of x. So f composed with g at x is f of g of x. All right, now let's do the steps. So once we get to that, remember you got to find this g of x. So what's g of x equal to? Well, g of x is this. So now I'm going to replace this with this expression. So replace that with this. All right, so this becomes f of 3x minus 6. So again, notice what this is. G of x equals what? 3x minus 6. So you're going to take g of x and you're going to put it inside of the function f. So you're going to take 3x minus 6 and you're going to put it inside the function f. So remember, function f was this. F of x equals 2 minus 5x. That's what f of x equals. So I'm going to go to my function f, and where we see the variable x, I'm going to substitute that into x. I'm going to substitute into x 3x minus 6. So this becomes 2 minus 5 in parentheses 3x minus 6. So notice what you have. You see this right here? 2 minus 5x. Remember, this was x, right? Well, what am I replacing x with? I'm replacing x with 3x minus 6. So that's what you have. But now you got to distribute, though. So when I distribute, I get 2 minus 15x, and then negative 5 times negative 6 is positive 30. So you get negative 15x plus 32. And so that is, right here, that is f composed with g at x equals negative 15x plus 32. Okay? Part B. Okay, in part B, suppose you wanted to find, in part B, same functions, but this time instead of saying f composed with g at x, let's find g composed with f at x. Okay, g composed with f at x. Okay, use the definition. By definition, what is this equal to? Well, it's equal to g of f of x. That's what that's equal to. Okay, by our definition. And so I got to find that f of x first. Well, f of x, remember, f of x is this right here, 2 minus 5x. So this has become g of 2 minus 5x. That's what that equals right here. Okay, right here. So f of x equals this. So now what that means is I go to my function g, and wherever we see the variable x, remember this was g of x was 3x minus 6. So I got my function g, and wherever we see the variable x, I'm going to substitute 2 minus 5x. So that's what that means. So then this would become 3 times x. What do I replace x with? I replace x with 2 minus 5x. And then don't forget the minus 6. So now you can distribute. And so you get 6 minus 15x minus 6. 6 minus 6 is 0, so all you're left with is a negative 15x. So g composed with f at x is equal to negative 15x. That's what it equals to. All right, now C. Suppose you want to find this. Suppose you want to find f composed with g at 4. F composed with g at 4. All right, well, there are two ways you can do this. I want you to notice something. I already found f composed with g at x, right? Didn't I already find this? That was this one here, right here. So wasn't f composed with g at x equal to this expression? So we found f composed with g at x to equal negative 15x plus 32. So if we want to find f composed with g at 4, so that means in place of x, I'm going to substitute what? 4. So in place of x, I'm going to substitute 4. So this becomes negative 15 times 4 plus 32. So in place of x, I'm going to substitute 4, because we already found this. We found this in the previous part. So I get this. So negative 15 times 4 is a negative 60. Negative 60 plus 32 is equal to a negative 28. All right, so f composed with g at 4 equals to negative 28. But what if you did not remember this? What if you forgot all about this? All right, well, here's the other way. No big deal. Here's the other way. Well, remember, f composed with g at negative 4 means f of g of 4, right? F of g of 4. So then, just like before, I got to find g of 4 first. So I go to my function g, and where we see the variable x, I plug in 4. So remember, g of x was this, though. Here's g of x. G of x is 3x minus 6. So I go to my function g, and where we see the variable x, I plug in 4. So I get 3 times 4 minus 6. So that's 12 minus 6, which is 6. So that's g of 4. So then this becomes 6 right here. So then I can say f of 6. So now that says I go to my function f, and where we see the variable x, I'm going to input 6. So my input here was 4. I got this output. Now this output becomes the input for f. So I go to my function f. Remember, f of x was this. Here's f of x. It was 2 minus 5x. So I go to my function f, and wherever we see the variable x, I'm going to substitute 6. So I get 2 minus 5 times 6. And so 2 minus 30, which is a negative 28, which is what we got. Okay, right here. All right. So it didn't matter which approach you took. You got to be careful though, because this could have been an error. Remember, we could have made an error right here. We could have made an error. So to be on the safe side, do it both ways. If you do it this way, definitely do it the other way, because you could have made an error somewhere in your calculation here when you combine like terms, or when you substituted that expression. You could have made an error. So if you do it this way as well, to verify that what you have is correct. All right, let's look at D. All right, suppose D, I had this. All right, D, let's suppose we had, all right, suppose you want to find g of f of negative 2. G of f of negative 2. I'm going to go ahead and do it you just go ahead and using the definition. So by definition, that means g of f of negative 2, right? So then that means I'm going to my function f. And f of x, remember, was this, was 2 minus 5x. And so where we see my function, I go to my function f, where we see the variable x, I'm going to substitute negative 2. So then this becomes 2 minus 5 times negative 2. So that's 2, and then this is positive 10, so I get 12. So f of negative 2 is 12. Now remember what you got to do next. You got to go here, and in place of negative 12, you're going to rewrite that as, in place of negative 2, you're going to rewrite that as 12. So f of 2 is 12. And so now you're going to go to your function g, and wherever you see the variable x, you're going to substitute 12 now. So remember, g of x is 3x minus 6. So in place of x, you're going to substitute 12. So I get 3 times 12 minus 6. 3 times 12 is 36, so 36 minus 6 is just 30. So g composed with f at negative 2, g composed with f at negative 2 equals 30. That's what you found. All right, let's look at one more problem with this. All right, let's suppose in number 4, number 4. All right, let's suppose that f of x is 2x minus 7, and g of x is 3x squared minus 2x. So let's say that's what we had. Okay? All right, part A. Let's find f composed with g at 3. F composed with g at 3. Let's make it negative 3. At negative 3. Negative 3. All right, so we got to use the definition. Now, before we go on, make sure you understand that there is a difference. I'm going to write this on this one. There is a difference between this and this. So f composed with g at negative 3 versus f, it looks like this. So this is composition, this is multiplication. All right. So composition here means this. F of g of negative 3. That's what that means. This right here, multiplication, means f of negative 3 times g of negative 3. You see the difference? So it's important you see the difference. So this means f of g of negative 3. This means f of negative 3 times g of negative 3. That's what that means. See, it looks different. Okay, so keep that in mind. So open circle is composition. Closed circle is multiplication. That's multiplication. So multiplication. And this is composition. Okay? Composition, multiplication. Open circle is composition. Closed circle is multiplication. Notice how it looks. It's different. Okay, so let's go back to this. All right, by definition, remember that by definition, this means f of g of negative 3. Okay, so that's where we're at. Now, what's the first thing you got to find? Well, you got to find g of negative 3. So let's go off to the side, figure out what g of negative 3 is. Just go off to the side. G of negative 3. Well, that says I go to my function g, and wherever we see the variable x, I'm going to substitute negative 3. So here's my function g. So I'm going to substitute negative 3 into x. So I get g of negative 3 will be 3 times negative 3 squared minus 2 times negative 3. So wherever we saw the variable x, I substituted negative 3. You see it? 3x squared minus 2x. So x became negative 3. Order of operations, I got to do the exponent before I multiply. So negative 3 times itself is 9. 9 times 3 is 27. Negative 2 times a negative 3 is a positive 6. So this becomes 33. So g of negative 3 is 33. Okay? So you take that and you place g of 3 with that number you just found. So this becomes f of 33. So remember what you did was your input was negative 3, and this gave you an output. So you input 3 into g, and you got the output. So when x is negative 3, your y value is 33. But this output then becomes an input that I put into f. So my input into f, remember now this is where we see the variable x into f, you substitute 33. So this time, remember, f of x is this. I'm going to write it here. F of x is 2x minus 7. So where we see the variable x, I'm going to substitute 33. So I get 2 times 33 minus 7. So that's 66 minus 7, which is 59. So what I found is this. So f composed with g at negative 3 equals 59. Okay? So f composed with g at negative 3 equals 59. Okay, B part. Suppose you had this now. Suppose you want to find f composed with g at x. F composed with g at x. So it's no longer a number. So remember, when I found f of g at a number, I ended up with a number as my answer, a real number. But here, that's not a number, that's a variable. So I'm going to end up with a variable expression. But I'm still going to use the definition. By definition, remember, this means f of g of x. That's what that means. And just like when I found out what g of negative 3 was first, I'm going to find out what g of x is first. Well, what's g of x? Well, g of x, remember, is this expression, 3x squared minus 2x. That's what that equals. So in place of g of x, I'm going to substitute this whole thing right here. So this becomes f of, remember, I'm replacing this whole thing, so 3x squared minus 2x. That's what that becomes. And so now this says, I go to my function f, and I'm going to input, where we see the variable x, I'm going to input this expression. That's what that says. So remember, f of x was this. It's 2x minus 7. That was f of x. So I go, and I'm going to input this expression right here. So in place of x, I'm going to substitute this 3x squared minus 2x. So I get 2 times, right here, so that's going to equal 2 times 3x squared minus 2x, and then minus 7. So then I'm going to distribute. So I get 2 times 3x squared is 6x squared. 2 times a negative 2x is a negative 4x minus 7. And I can't combine anything, so there's your answer. So f composed with g at x is equal to 6x squared minus 4x minus 7. That's what it equals to. Okay? All right, C. Let's suppose you had this. Suppose you want to find g composed with f at x. All right, now this is going to be a little bit more challenging. You're going to see why. But you want to find g composed with f at x. By definition, this means g of f of x. You got to know your definition. So I'll find this first. Well, first, f of x equals 2x minus 7. That's what f of x equals. So in place of this, I'm going to substitute 2x minus 7. So this becomes g of, and we're replacing f of x with this now, 2x minus 7. And so now that says I go to my function g, and remember g was this quadratic, that was g, and that says wherever I see the variable x, I'm going to substitute 2x minus 7. So write it out first. So that becomes 3 times x. What do I substitute for x? I substitute 2x minus 7. But remember, that's being squared. Minus 2 times, what do I substitute for x? I substitute 2x minus 7, in parentheses though. So that's where I'm at. Okay, so remember, you cannot distribute here because of that exponent. The only time you can distribute, see, I could distribute here, but I can't distribute here. I can't say that 6x minus 21 squared. That's not true, because this thing is being squared. So if the exponent's 1, then you can distribute. But this exponent is not 1, that's a 2. So remember, you got to square first, the order of operations. You have to square first and then multiply. So let's go off to the side and figure out what 2x minus 7 squared is. Well, 2x minus 7 is 2x minus 7 squared is 2x minus 7 times itself. So when I use the FOIL method, 2x times 2x is 4x squared. The outer is a negative 14x. The inner is also a negative 14x. But the last, a negative 7 times a negative 7 is a positive 49. Then combined like terms, I get 4x squared. A negative 14x and a negative 14x is a negative 28x, and then plus 49. So now what I found was this right here, just this right here, is this trinomial. That's what I found. So again, what I found was this. I found this right here. This right here is this. So in place of this binomial squared, I'm going to substitute it with this trinomial. So I'm going to get, don't forget those being multiplied by 3. So I'm going to get 3 times 4x squared minus 28x plus 49, and then minus 2 times 2x minus 7. And so now I'm going to distribute. And so when I distribute, I'm going to get 12x squared. 3 times 28 is 56x. I get minus 56. I'm sorry, that's not 56. Let's see, 28 times 3, that's, what's that, 84? So minus 84x, okay? And then plus, and then 3 times 49, I don't have a calculator, so I'm going to do it by hand. 3 times 49, it should be 147, because if that was 50, that would be 150, and then subtract 3 would be 147, but it's 147. So 9 times 3 is 27, 12 plus 2 is 14. And then distribute here, you get minus 4x, and then what's that, plus 14? Combining like terms, put in descending order, I'm going to get 12x squared. A negative 84x and a negative 4x is a negative 88x. A positive 147 and a positive 14 is a positive 161. Okay? All right, and so all of that work right here, this answer right here, is the answer to g composed with f at x. So g composed with f at x, in the blank you're going to put this trinomial, 12x squared minus 88x plus 161. Okay? All right, so that is the composition of two functions. So just make sure you go over this, do the worksheet dealing with this, and you should be okay. That should be enough for you to understand what to do. So that takes care of this lesson.